All right, welcome to pre-calc again. We are talking about measures of angles today. Okay, so this is not too terrible of a section, but there is a lot of like little addition and subtraction. When in doubt, draw it. Okay, when intro to trig, one of the first classes I ever took. We had a nice teacher for that one, and every time we turn into a problem, we go to his office and say, "What do we do?" He's like, "Did you draw the triangle yet?" Like, no. He's like, "Why don't you draw the triangle?" We draw the triangle. I was like, "Oh, there! I think the answer is this." Okay, great. So that's what we're going to be doing. All right. So first thing is there's a couple of different measures of angles. Okay, you are probably used to here's the circle, right? There's 360 degrees in a circle. Okay. Now, if I make my radius here 1, r is equal to 1, what is the circumference of that circle, right? And the circumference is 2 pi r. In this case, it's 2 pi 1. Okay. So as long as we're dealing with, this is how they come up with the unit circle, because the unit is when r is equal to 1. Okay, that 360 degrees is equal to 2 pi. Okay, we're going to call this a radian. Okay, that's what this is. So if I divide both sides by 2 pi, we have 1 radian, right, is equal to 360 degrees divided by 2 pi, or 180 degrees divided by pi. That's equal to 1 radian. Okay, if you do that on your calculator, 180 divided by pi, it's like 180 divided by 3 is about 60 degrees. So 180 divided by pi, 1 radian is about 60 degrees, right? Yeah, 1 radian is about 60 degrees. Now, technically, radians don't have a unit of measure, so we do this the other way around. We're just going to call it 2 pi, and we're not going to worry about the measures. So when we're measuring degrees and radians, right? We're measuring angles and radians. We just say, well, that's just, we don't have a unit of measure. Okay. I'm going to rate it in for the first few times just to get you the idea that we're talking about a radian here. But in general, in your futures, radians don't have units. So we just say it's 2 pi because it's just a length. Okay. It's just a distance around the circle. Okay. All right. So we can go the other way around, right? There's 360 degrees in the circle. That's equal to 2 pi radians. We divide by 360, divide by 360. So we have 1 degree is equal to pi 360 over 2. That is going to be 180 radian. Okay. So 1 degree, okay, that's a very small unit, right? And we are going to have pi, oops, I don't want that. I want pi over 180, and it's going to be a tiny number. So 0.017. Okay, so 0.017 radians. Okay, so 1 degree, 0.017 radians. All right. There's another unit if you have an older calculator, and I hope you do. You're going to see a GRAD. This is called radians. This was a unit that was developed after the French Revolutionary War because that's when the metric system happened. And the French kind of went nuts with metric, so everything had to be between 0 and 100. So instead of this being 90 degrees, we would say that this angle was equal to 100 radian. Okay, so 0 to 100 radians. Okay, so 400 radians in a circle. Wasn't used all that much. I don't know why it made its way into calculators, but you know, if you ever want to write a post-French Revolutionary historical romance novel featuring a French artillery officer, there's your unit, okay, to make it look authentic. Okay, so there you go. That's what a gradient is. We don't really use them. Okay, we do have degrees minute, second. Okay, that's another way of measuring angles with degrees. And I'm going to ask you, like, well, how many minutes are an hour? So 1 degree is equal to 60 minutes. Okay, 60 minutes is equal, sorry, 1 minute is equal to 60 seconds. Okay, just like regular. So when we get to these, I'll show you a couple ways to do this, but this is still used. I know that the U.S. Army still uses this for surveying. Surveyors still use this method. So this is still in. You'll see this. Okay, you'll never see radians, but that's another measure. Okay, rather than we use decimal degrees, we use minutes and seconds. All right. So let's see here. That's pretty much the idea, okay, of what's going on with the measures of angles, right? Now, we know that that's 90 degrees. Right? If I know that a circle is 2 pi, what's half of the circle? Well, half of the circle, I've got colors, we can do this. Okay. Half of the circle here, that is 1 pi. Okay, so half a circle is 180 degrees, which is 1 pi radians. Okay, a quarter of a circle, that's what I drew here. Okay, a quarter of a circle, 90 degrees. Okay, a quarter of a circle, this part, right? That is 2 pi divided by 4, which is pi over 2, right? 2 quarters is a half. So 2 quarters, that's 1 quarter of a circle, okay, which is 90 degrees. So 90 degrees is pi over 2 radians, okay? Now there's a couple of triangles, a couple of angles that occur over and over and over again, all right? So that is right, the 45 degrees. Okay, so these are to the same length. Okay, so we have a 1 and a 1. Right, that's square root of 2. But if I go with a quarter of a circle, we're going to say this is right 90 degrees divided by 2. That's 45 degrees. Okay, 45, not 15. If I say this is pi over 2 divided by 2, this is really pi over 2 times 1/2. That's how that works for fractions. So that is pi over 4 radian. Okay, so 45 degrees and pi over 4 radians, that's the same thing, right? What about 90 degrees divided by 3? Okay, that's equal to 30 degrees. Okay, so we have pi over 2 divided by 3. That's equal to pi over 2 times 1/3. That's pi over 6 radians. All right, and then if we multiply this by 2, okay, so we take 30 degrees times 2, that's 60 degrees. We want pi over 6 times 2, that is equal to 2 pi over 6, which is pi over 3 radians. Okay, so those are important ones to remember. Like I said, I'm going to keep writing the radians. I'll try to write the degrees and the radians at the same time because honestly, it takes about 2 weeks for people to get really comfortable with going from degrees to going to radians. Okay. When you take your Calc 1 or your Physics 1 classes or your engineering classes, they will often use degrees as the unit of measure for angles. And in your calculus class, they will only use radian, well, not only, but they will often use radians. So the important thing you have to do is when you have your physics class and your calculus class, and then you'll be able to use one of these calculators. What you want to do is the first thing you want to do is want to go to mode, and you see here, down here it says radian or degree. You need to change between the two of them. Okay, all the calculators also have radians, but you want to make sure you're in the right mode when you are going to your right class. Okay, so right now the mode is, oh, thought I changed it to degree. Right, enter, and then quit. Back to mode, I'm in degrees. Okay, so that's how you change it. All right. So be careful about that. That is one of the most common mistakes people make. Okay. When you have physics class and your calculus class in the same semester, I don't think the teacher would mind if you were the first person in the class and you wrote down, change your calculator back to radian mode, or remember to change your calculator to degree mode when you walk into physics class. So you put that on the board. I think the teacher was like, oh yeah, thanks for reminding me for having you guys do that. And I think your fellow students would be most appreciative that somebody reminded them to change the modes of their calculators. So if you all remember, then somebody writes it down, then nobody's going to make that mistake. Because I don't want to, I don't want to change things. Like if you guys are doing something with 45 degrees and you forgot to change it, and now you're talking about 45 radians rather than 45 degrees, I don't want to mark you off on that answer in Calc 1, Calc 2, or physics, because this is a basic mistake. Okay. Shouldn't fall for it, but people do, because that's how people are. But just be aware, you got to change them. Okay. So why don't I just take us through the homework a little bit and see where we end up. All right, it'll probably be a part 1. Okay, we'll try to do a part 2 in a minute here. All right, so let's go ahead and we'll say preview. Start the assignment now. Okay, and we'll just go through some of this. Okay, 135 degrees, all they want us to do is drag the angle. 135 is, well, it's bigger than 90, it's 180. So we could say, well, what's 90 plus 180? Can we average them together maybe? Okay, we'll see. That's 270. 270 divided by 2. We get 1. Oops, that's 0, 3. That's a 6 down here. That's 10. So 135 is the average between the 180, right, and 90. So it's going to be right there. All right. You don't have to have done that. It's okay. All right. If you know where it is, that's fine. But we're talking about halfway between. Is that halfway? Or do I want to go there? Yeah, it's kind of hard to tell. We'll talk that. We'll say that's halfway. All right. I'm not going to guarantee I'm going to get the right answers all the time here because, yeah. Okay, 60 degrees, right? We're up there. Okay, if you cut pie for a living at all, ever, Thanksgiving, you were pressed into service, you're going to be familiar with this. Negative 135. We go around the opposite way. Okay, that's all we're doing. We're just going around the opposite way. Make sure that's the same. Boom. Nope, didn't like it. What is the instructions to say? Sketch the angles in standard position. Well, standard position means we have to go right here. And since that's the angle we want, all right. So how do we do that? That's going to be negative 135 plus 360 is equal to what? Okay, that'd be terrible. Negative 135 plus 360. To get it positive, we get 225. Okay, I still like my third quadrant type thing here, except they want it in standard position, so we have to go around there. Go this way and say, great. Oh, one last time. What are you doing? I thought that would be okay. Let's see if they're going to do that. Didn't like it at all. Okay, so it looks like I needed to be a little bit more careful about how many little tick marks I went. Okay, so okay, like I said, it wasn't going to be the same thing. Negative 79. So now I know where negative means. We're going to go down to 90. And then what do we have? How many ticks do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Can we not show this? All right. How many ticks do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So let's see here. We have 90 degrees divided into 18 little parts here. So we have 90 degrees divided into 18. 18 times 5, right? That's 90. So these are each 5-degree portions. Okay. So if we go to there, and then we just go a little bit less, which I'm guarantee you they're going to tell me is the wrong answer. But there we go. Oh, they left it. Okay. Must have a wider variance or wider margin of error there. Okay, but each of these is 5 degrees, so that's how we can tell. All right, great. All right, so be a little careful with that, but next. All right, use a conversion factor. Pi equals 180 degrees, and the symmetry of the angle to complete the following radian measures of the missing angles. All right. So pi over 3, we just did that, right? Pi over 3 was equal to 60 degrees. That's one you're going to know. Okay, that's one you have to know. All right. 120 degrees. Well, I don't know for 120 degrees. Well, actually, that's 60 and 60, isn't it? So 120 degrees. Where is 120 degrees? Right, this is equal to 60 plus 60. So we have a 60-degree angle and then another 60-degree angle. So we're going to be using this one. So let's go ahead and try it. So this is going to be 120 degrees times pi over 180 radians. Okay. So the degrees will cancel out. Okay. So we'll have 120 over 180 pi. Okay. Don't multiply the pi out. Just let it be there. Okay. And then say that's 12 over 18, which is 2 times 6 times 3 times 6 pi. So 2/3 pi radian. Or you could have doubled the 60 degrees either way. Okay. So this is going to be 2/3 pi. All right. 180. We know 180 is pi. We don't have to do that one by hand. They told us. 7/6. What is 7/6 radians? 7/6 pi. What's 6/6? 6/6 is 180. So we have to go 1/6 more. Do you remember what 1/6 radians is for degrees? Right here. Pi over 6 radians is 30 degrees. So what we're going to do is we're just going to add, right? We're going to say 130 plus that and 210. What if you didn't remember that? What if you didn't? Or you didn't like it? Okay, we're going to do 180. No, we're going to do pi over 180, right? That's how we're going to do this. Oh, we have to go the opposite. Sorry. So we have to do 7 pi 6, 180 over pi. That's how we're going to go. Okay. So this is going to be 7 times 180 over 6, right? The pi's are going to cancel. So we have pi over pi. Those are gone. 180 over pi, that was 30, right? 6 times 30 is 180. Okay. Times the 7, that is equal to 210 degrees, which is exactly what we had over here. Okay. So either way, pick which method you like to see, pick which method works for you, pick which method, that you can verify to yourself that that's the right answer. Okay. So 315, I know that's going to be the 45 degrees in the fourth quadrant. Okay. But how do you do? So you'll say 315 degrees. So times pi over 180, right? Yeah, because we're going in the radians. So we want the pi on top here. So this is 315 over 180 pi. Let me show you a little trick here with your calculators. Okay. This is going to be 315 divided by 180. All right. And then you don't like that, okay, because it's not, maybe let's pretend it's a harder fraction, okay, as opposed to 7/4. So what you're going to do next, you're going to do math fraction is convert your answer into a fraction, and we'll get 7/4. Okay, 7/4 pi. So that's how you do that. Let's see. Yep, I don't want that one. I want this one. Okay, so that's 7/4 pi. Oops. Nope, not there. There we go. All right, and then 2 pi is equal to 360 degrees because that's once around the circle. All right, so we're going to be okay there. All right, let's move on to a different one. Okay, convert negative 160 degrees to radians, give the exact form in terms of pi. Okay, so we have to go back to our conversion factor, right? And we know that 360 degrees is equal to 2 pi. So 1 degree is equal to 2 pi over 360. So that is going to be pi over 180. All right. So if we have negative 160 degrees, that's going to be negative 160 times pi over 180. Okay, so those will cancel out. So we've got negative 16/18 pi. We could do a little better, don't you think? So that's going to be 2 times 8, 2 times 9 pi. So those cancel. We have 8/9 pi. Don't forget the negative. So we have negative 8/9 pi. This is not one of the ones that are magic that you have to memorize. So I think that's nice, but we're not, we'll probably never see this ever again. Okay, so we're going to say negative 8/9 and then pi. All right, and we'll see if they take that. Oh, they did. Okay, try another. So let's go with number 8. Okay, convert 7/12 pi from radians into decimal degrees. Actually, we're not going to need the degrees, but I'll show you, because 12ths are a oh nope, we will. That's 15 degrees. Pi over 6 was 30 degrees. Half of that, 15 degrees. Okay, so 30 divided by 2. So here we have 7 pi over 12. Okay, and what we're going to do is we're going to say this is times 180 over pi, right? That's the conversion factor. So the pi's are going to cancel. So we have 180 over 12 times 7. Okay, like, why do I divide it up that way? Like, well, does 180 and 12 have anything in common? Like, maybe I could divide by 3. Okay. So actually, we could do this. We could say what's 180 over 12. So I think that goes into an even. It's 15. Okay, so this is 7 times 15, which is 70 and 35, right? This is 7 times 10 plus 5. Okay, so that's how I got 70 and 35, which gives me 105 degrees. Okay, learn that from a cartoon. So that's going to be 105 degrees. All right. Oh, make sure the rates are signed. What do they want me to do? I would have been careful if I. Oh, degrees. Okay, so hold on. Let's type in the degrees and say 105 degrees. Because again, degrees has a unit, radians do not. Okay, so thank you for reminding me. And see, I feel bad about giving you like so many problems, but a lot of these are just like one step, convert this to that kind of a problem. Okay, so I'm not too concerned, but yeah. All right, find the complement of the given angle. We're gonna convert this, so I can show you how to convert from degrees, minutes, seconds here. But we'll say what's the complement. Okay, and the complement is simply so what's a complementary angle? Do you remember? Right? Wasn't that 90? Like the two angles, A plus B, had to equal 90. Okay. By the way, quick thought. For angles, they use Greek letters. Okay. This guy here, this is pronounced theta. You know how every variable in algebra was an x? Every angle is a theta. Okay, then we have phi or phi. Okay, that's the next one that's usually used. And after that, people just kind of make up whatever letter, whatever Greek letter they're comfortable writing after that. Okay, so theta and phi are like the two usual. This is your x and a y. Okay, so, but we'll say A and B is equal to 90. That's what complementary means. So we have 19 plus 3, 19.3 plus B is equal to 90. B would be 90 minus 19.3. So that's going to be 90 and 19.3. And I don't want to do that. So we're going to say minus 1 minus 1. Okay, that's 89. That's going to be 18.3. So okay, we have 8 and we have 10 here, 7, 0, 70.7 degrees. That seems about right. Okay, 70.7 degrees. Supplementary. Okay, two angles are supplementary. If A plus B is equal to 180. Okay, so we have 19.3 plus B is equal to 180. B would be 180 minus 19.3. So we're going to say this is 179, right? 180 minus 1 divided or minus, right? 18.3, right? Subtract 1 from both of these. So that's 9. There's 10/10 of a degree. So that's 7. All right. That's 8 now, right? So that's a 0. That's a 6. That's a 1. So 160.7. All right. Oh, that's what I wanted. All right. Before I do the check answer, convert 19.3 degrees into minutes. Actually, here's the if you have one of the older calculators, that's a button on your calculator, degrees, minutes, seconds. Okay, so we have to take, well, there's 19 degrees, so that's 19. Okay, we have 0.3 degrees, so 0.3 degrees times 60 minutes per 1 degree. The degrees cancel, and we end up with 0.3 times 60, which should probably be like 18. So this would be 19 degrees, 18, not 18 seconds, 18 minutes. Okay, so that's another way to write that. Okay, and then if there was more decimals, we would go into seconds. All right, but 19 degrees, 18 minutes, that's how we would write that. All right, so great, let's go. Oh, it didn't like that. What didn't it like? Check the digits. One of them is wrong. Oh, I bet it's 69, isn't it? No, it isn't. Oh, there it is, right there. 7. All right, there we go. All right. Find a positive and a negative angle that is coterminal to 2 pi over 3. Do not use the given angle. Right. So we need an angle that's coterminal to 2/3 radians. Okay, 2/3 pi radians. Where the heck is 2/3 pi radians? Well, we always know where 3/3 pi radians is. So what we have to do here is divide this into thirds. Okay, so 1/3, 2/3, 3/3. All right, so here we go. Here's 2/3 pi radians. All right, now how do we find angles that are coterminal to this? Well, one thing we could do is we can go around twice, right? Or we can go around once. We can go all the way around, that's 2 pi, and then go that much further. So why don't we add 2 pi to this? Okay, so we have 2 pi over 3 plus 6 pi over 3, right? That's a fancy way to write 2. And we end up with 8 pi over 3. So that's one coterminal angle. Could have I added 4 pi? Sure. Could I have added 6 pi? Sure. Right? So those are all the ways to do it. Or we can go around in the other direction. This way. Okay. So what we're going to do is we're going to take our 2 pi, right? So that's all the way around, minus, right, 2 pi over 3. So we're going to go all the way around, less, right, the 2 pi over 3. So that is going to be 6 pi over 3 minus 2 pi over 3, and we end up with 4 pi over 3. I actually did this in a backwards order. I really wanted to go negative 4 pi over 3 because that's how we go around counterclockwise. All right. So 4 pi over 3 because we're going in the opposite direction that I usually turn in. Okay, so we have 8 pi over 3, negative 4 pi over 3. All right. So this is 8 over 3 pi. Right. All right, and then we have a negative 4 pi over 3. Negative 4 over 3 pi. Okay, so that's how we do those. Okay, not too bad. Just add and subtract 2 pi or some multiple, 2 pi, 4 pi, 6 pi, something like that. And that's how you're going to get your coterminal angles. All right. And find the arc length. Find the exact arc length interpreted by the central angle. Okay, here's your formula for arc length. Arc length, S is equal to R theta. Must be radians. Okay, so theta must be in radians. So the first thing we've got to deal with is the fact that we've got 360 degrees. Okay, so 300 degrees rather, not 360. 300 degrees convert to radians. Okay, so we're going to 300, right, times, how do we convert to radians? It's pi over 180. The degrees parts will cancel, so we have 300 over 180 pi. That cancels. Okay, so how do we do 30 over 18? 30 is 6 times 5. 18 is 6 times 3. So this is going to be 5/3 pi. Okay, and then that's our angle. That's our theta now. Okay, this is equal to theta. Okay, so remember this guy is called theta. Okay, it's the Greek X for angles. Okay, so my arc length is S is equal to R theta. S is equal to, we have a radius of 5 times 5/3 pi. Okay, so I should have written 5 instead of R because I'm filling in. So this is 25 over 3 pi. Okay, so exact, oh, they want it. How many decimals do they want this in? Here's 10th. All right, so 25, boom, boom, 25 divided by 3 times pi. 26 point, we'll say 26.2. All right, 26.2. Here's 10th. I didn't like that at all. What did I do? What did I not do? 26.2. Is that not what I wrote down? That is what I wrote down. Radius of a circle. Nearest 10th of a unit. 300 degrees looks 360 less 60 degrees, so that's 5 pi over 3. That I like that. 5 times all of this. Did I get that wrong? 5 times 5 is 25. 25/3. Double check. Okay. 25 times pi. Okay. Divided by 3. 26.2. I wonder. I'm just going to say recheck and recheck. Let's see what happens. Oh, okay. I misread the thing. They wanted the exact length first, and now they wanted the next one. All right, that's fine. Okay, remember, the decimal, anytime the decimal place, it is an approximation. Okay, unless it terminates. Okay, so there. Now we're happy. All right, I'm going to stop us here because I think this has been long enough. I will start us on the next one in the next section, okay? So I will see you in the next time. All right, good luck.